Good evening, everyone, and welcome to tonight's program. My name is Carly Rygard, and I'm the Children's Services Coordinator here at the Enoch Pratt Free Library. We're so happy you could join us for tonight's program. It is a part of Imagination Celebration, our celebration for ages 0 to 5 of creativity and imagination. This year's featured book is What Will You Be by Shamile Syed Mendez, and there are activities all month long featuring arts and crafts, STEM activities, take and makes, live music concerts, scavenger hunts, and more. So be sure to visit our website, prattlibrary.org/imagination for more information. But without further ado, I'd like to introduce tonight's special guests for our virtual planetarium, which include Alex, Jacob, and Ralph, all graduate students at Johns Hopkins University. And tonight we're going to explore outer space together and learn stories about the stars.
All right, thank you for the intro, Carly. We're all grad students at Johns Hopkins, and we'll be using a special software called Worldwide Telescope to tell you about a few constellations in the sky. So let me start sharing my screen. Okay, and hopefully everyone should see my screen now. Let me just stop my camera, sorry. Okay, so can everyone see my screen? Just feel free to just say yes or no using your mics.
Looks great.
All right, thank you. So before we start, I just want to advertise the software we're using. This software is called Worldwide Telescope, and it's available for free online. Worldwide Telescope is a virtual planetarium that lets you look at different images of the sky that are prepared by astronomers, as well as search deep sky objects like galaxies or star clusters. There are pre-made shows that you can watch to learn more about different kinds of things in space. And so we'll start.
When you look up at the night sky, do you ever see stars close together that look like shapes? And if you go far away from city lights, you can see hundreds of triangles, rectangles, and other shapes made by the stars. We're showing you an image of the sky. Do you see any shapes here? These shapes are made up of stars and are what astronomers call constellations. Can you think of any constellations that you know of?
People have been creating and naming constellations for thousands of years all over the world. Today, there are 88 official constellations astronomers use to point out things in the sky. The red lines you see here are the constellations astronomers use. We're going to look at 3 constellations and learn how they got their names and what kinds of things lie within them.
The first constellation we're going to is called Cassiopeia. It looks like a squiggly W-shaped constellation that you can see from here in the northern hemisphere. It gets its name from a queen in Greek mythology who thought that she and her daughter Andromeda were the most beautiful women in the world. Andromeda is also the name of a famous galaxy close to our own Milky Way. The Greek god of the sea, Poseidon, was mad at Cassiopeia, so he punished her by placing her in the sky, chained to a chair. Poseidon also chained Andromeda to a rock where she was going to be eaten by a sea monster until the hero Perseus rescued her. The W shape in the constellation shows Cassiopeia being chained to her chair, as you can see in this image here.
Other cultures see different things in what we call Cassiopeia. Chinese astronomers saw a chariot and a whip in Cassiopeia. Arab astronomers saw a camel using some of the stars in Cassiopeia. And the Sami people of northern Finland saw moose antlers where the W is. And you can kind of make that out here.
A section of our Milky Way galaxy runs through Cassiopeia, and the constellation is full of amazing things. 450 years ago, a star exploded in Cassiopeia. When this happens, the explosion makes the sky very bright, and the astronomers call it a supernova. The supernova was seen and studied by the astronomer Tycho Brahe. Brahe saw and wrote about many objects in the sky, and his measurements helped Galileo, another famous astronomer, discover that the Earth goes around the sun. Brahe also wore a metal nose, which he got after fighting in a duel. This image shows what remains after the supernova, called a supernova remnant. It was taken by the Chandra X-ray telescope and shows material that was released by the star during the explosion and swept up into the surroundings. This material can reach millions of degrees and get really, really hot and shine bright like a light bulb, but in a different color, like what your dentist uses to look at your teeth. The hottest material is shown in blue, and the coolest material is shown in red.
Not far from Tycho Brahe's supernova remnant is another supernova remnant called Cassiopeia A. Here is a special image of the supernova remnant taken by 3 different telescopes, all of them in space. There's the Spitzer Space Telescope, the Hubble Space Telescope, and the Chandra Telescope. The red colors in the image come from Spitzer and is light redder than the red our eyes can see. This kind of light is called infrared light. The gold colors come from Hubble, which is close to the yellow our eyes can see. The green and the blue colors come from Chandra, and they show X-ray light, which is light much, much bluer than our eyes can see. Astronomers think this supernova exploded about 330 years ago, but we don't know if anyone saw it or wrote about it. When the supernova material moves further and further into space, some of the material close to the original star that had exploded cools down. You can see this material with yet another kind of light called radio waves, which are like the radio waves you hear in your car.
So not too far from the supernova remnants are something called the Heart and Soul Nebulas. We're going to take a little trip across Cassiopeia this evening. So right now we're zooming out, and over on the left side here is this really, really cool image taken by another space telescope, we went into too much, called the WISE Space Telescope. And the WISE Space Telescope looks at infrared light like Spitzer. And this is kind of like using night vision goggles to look at the heat coming from someone's body. Nebula means cloud in Latin, and astronomers use this word to describe objects like these because they kind of look like clouds in the sky. These nebulas are full of gas, heated up by young, bright stars. When the gas is heated by these stars, it glows in certain colors. Can anyone see the heart shape of these nebulas? It's this one on the right. Okay, let's move on to the next one.
All right. Here we go. Let's move on to the next constellation, all the way in the southern hemisphere. This constellation, made up of 4 stars, is named Reticulum. Reticulum means net in Latin, like the net you'd use to catch a fish. A lot of constellations in the southern hemisphere astronomers use today were created after Europeans began exploring and colonizing the New World. This constellation received its name roughly 270 years ago and is one of the younger constellations. Many southern hemisphere constellations are named after instruments, like horologium, which means clock in Latin. During the Age of Exploration, Europeans used many instruments to explore the world, so constellations were named after their instruments.
Reticulum is one of the smallest constellations in the sky, so there aren't many large objects, like the nebulae we saw before, found in it. But if we squint a little, Reticulum has some amazing galaxies, like the one we're showing you right here. This image shows NGC 1559. It was taken by the Hubble Space Telescope and shows the galaxy in visible light, the light that you can see with your eyes. This galaxy is 50 million light years away and is full of new stars that were just born. The blue and purple colors in the image come from all the new stars in this galaxy, which are spread out throughout those spiral arms. So many stars are born here that occasionally we see some of them go supernova and explode like we talked about before. Astronomers have found 4 supernovas in this galaxy in 1984, 1986, 2005, and 2009. The three supernovae before 2009 were all discovered by an amateur astronomer, not a professional, and perhaps you'll observe the next supernova in this galaxy.
So on the other side of Reticulum, there's another galaxy called NGC 1313. I'm going to take a trip to it now. And NGC 1313 has a funny name. It's called the Topsy-Turvy Galaxy. So here it is. This galaxy is 15 million light years away and is also full of new stars. You can see some of these new stars in this red and yellow color. This image is taken by the Very Large Telescope at the European Southern Observatory in Chile and shows the galaxy in light we can see. The new stars are in red, they're in green, and they trace the spiral arms of this galaxy, like the previous one we saw. This galaxy gets its name from its odd shape and how it rotates. Sometimes galaxies look like this after two galaxies collide with each other, but the Topsy-Turvy Galaxy appears to be alone. How it got its shape continues to be a mystery.
All right.
Hold on. My laptop's freezing a bit. Sorry.
You're good.
Let's see. Sorry, guys. It looks like we're kind of stuck with Worldwide Telescope. It's not moving right now.
While we're stuck, feel free to type any questions you have about what we've talked about so far, and we're happy to answer them.
Let's do that. Let me see if I can.
Stand by, we are experiencing technical difficulties. Jacob and Ralph, it looks like we do have a question. Freya wants to know, what is the biggest galaxy?
That's a really good question. And let me start by telling you how big our galaxy is. So it's pretty hard actually to measure a galaxy that you exist within. But if we observe as many stars around us that we can figure out how many stars we think are in the galaxy overall. Because as the stars move around the galaxy, they follow an orbit, just like Earth orbits the sun orbits the Milky Way. And by measuring how the stars orbit the Milky Way, we can figure out how many stars are in the Milky Way. And so there are around 100 billion stars in the Milky Way, which is a really big number. The largest galaxies we observe, which are very, very far away, I think are about 10 times bigger or more. And I don't know exactly which is the biggest galaxy in the entire universe that we've seen yet, but I'm going to try and find out for you.
Can you hear me?
Yes.
Yeah.
Sorry about that. It just froze. I don't know what was going on there. My apologies. I've removed one of my monitors, so let's try this again. We had one thing in the show, and then we'll be done with the prepared programming. So let me try that again. My apologies, everyone.
No worries.
Yeah,
All good.
Okay, great. Let's see. All right, can everyone see my screen?
Yes, we can. Go ahead and hit full screen.
Okay, let's try that again. All right, and then we can go back and forth. Great. Okay, so we left off with Reticulum. Unfortunately, I do need to do one quick thing before we can continue. So my apologies. I'll try to do one quick thing. So, okay, and then I'm going to share my screen again. Okay, great, and hopefully you can see the program again. Can you see it?
Yep, that works.
All right, good. So everybody, let's resume the show.
All right. Our last constellation is not really a constellation, but it's probably something you've heard of before, the Big Dipper. The Big Dipper is part of a larger constellation, Ursa Major, or Big Bear in Latin. The Big Dipper gets its name as it looks like a cup with a long handle. The Big Dipper is close to the star Polaris. Polaris doesn't move throughout the night, so the Big Dipper can be used to find your way north.
Since the Big Dipper is easy to find, many cultures have stories about it. The ancient Greeks named the constellation the Great Bear after the king of the gods Zeus went looking for someone. Zeus's wife, Hera, protected this person by turning them into a bear. Ancient Indian astronomers named the Big Dipper Saptarishi, named after 7 wise, accomplished people described in the ancient Indian text called the Vedas. Some stars in the Big Dipper are also mentioned in the Bible, and many Native American tribes see the constellation of Ursa Major as a bear, too. The Iroquois, for example, point to certain stars in the Big Dipper as hunters looking for the Great Bear in the sky. The Big Dipper has even made appearances in art, such as in Van Gogh's Starry Night over the Rhone, and also in the flag of Alaska.
So the Big Dipper and the rest of Ursa Major take up a lot of space in the sky, and many famous objects are found in this constellation. So in the handle of the Big Dipper is a double star called Mizar. I'm going to zoom to Mizar now. All right, that's a little close, but you can see there are these 2 bright stars next to each other. So Mizar, the bright one here in the center, has a companion named Alcor, which is this bright one to the left. These 2 stars are very close to each other, and you can even see them with the naked eye. Powerful telescopes have shown that Mizar is part of its own system of 4 stars, and Alcor is part of a 2-star system. The Mizar-Alcor system is the first system of 6 stars discovered.
In another part of the Big Dipper, there are bright and beautiful galaxies, Messier 81 and Messier 82. There we go. These galaxies are about 12 million light years away. This image, taken by an astrophotographer, so someone just taking pictures of the sky, shows the 2 galaxies, which are about 1 degree apart. These galaxies are interacting and will likely merge in a few billion years, so in a long time. On the other side of the Big Dipper is Messier 101. Whoa. Or the Pinwheel Galaxy, a gorgeous spiral galaxy that's making a lot of new stars. The Hubble Space Telescope took this image, and the new stars are shown in the blue color. A different type of object we can see is in the constellation is Messier 97, or the Owl Nebula.
You may,
Here's the Owl Nebula. This kind of object is called a planetary nebula and is made up of gas that was shed by a star in its late life. The star didn't explode or go supernova, but you could say it lost a lot of weight. This image was taken as part of the digitalized sky survey, which was responsible for taking all the images of the background sky we've seen thus far. The owl-like appearance of this nebula is caused by material shed by the star moving in different directions.
you may have heard the name Messier a lot just now. The last 4 objects we've seen are part of a big list of objects called the Messier Objects. This list was created more than 250 years ago by an astronomer, Charles Messier, who is interested in comets. Telescopes back then were not as powerful as they are now. So to Messier, these galaxies and nebulas looked like comets, but they didn't move. He wrote down where these objects are so he wouldn't have to visit them again when he was searching for comets. Just by accident, he left us with one of the most famous lists of objects in the sky, and he wasn't even interested in any of them.
So lastly, just above the Big Dipper is a piece of sky that's very special to me and a lot of people at Johns Hopkins. 25 years ago, the Hubble Space Telescope stared at a piece of sky for more than 100 hours to find the furthest galaxies possible. All the galaxies we've seen so far are less than 100 million light years away. The galaxies that astronomers wish to see using Hubble are more than 1 billion light years away, when the universe was less than 20% its current age. Hubble not only saw these galaxies, it saw thousands of them. The patch of sky we're going to right now is called the Hubble Deep Field, and it started a whole new field of astronomy. Each of these points you're looking at is a galaxy that is billions and billions of light years away, when the universe was much younger than it is now. I study these galaxies and how they change over time to better understand how they become the galaxies we were seeing earlier.
We've seen 3 different constellations located all over the sky. Constellations like the Big Dipper have been known for thousands of years, and others, like Reticulum, were created only a few hundred years ago. These constellations help us find our way across the sky and across the Earth. Astronomers have used these patterns to discover all the wonderful things the universe has to show.
Okay, and with that, we're happy to take questions you have about constellations or other things in the sky.
So I want to follow up on that question we got earlier about what's the biggest galaxy. So I didn't know this before you asked this question, but I learned that the most massive galaxy is probably 1,000 times more massive, 1,000 times bigger than the Milky Way, and probably twice as wide. Alex, do you want to answer the question about how did the first star happen in the universe?
The first star?
Yeah.
Well, so stars are made out of gas, and not too long after the Big Bang, gas was able to begin to cool and attract itself due to gravity, and over millions of years, it will eventually be able to get hot enough inside to form a star. And so the first stars we think occurred within maybe a few million, maybe about a few million, tens of millions of years after the Big Bang. And hopefully with the James Webb Telescope that launched not that long ago, we might actually be able to see them, if not the very first galaxies that were formed.
So we're going to take a few moments to see if any other questions come through from our audience. So please, if you do have any questions, post them in the chat and we'll make sure to share them with the Johns Hopkins University team here. In the meantime, I did want to mention that if you haven't already done so, please be sure to stop by one of 5 of our locations. Thanks to the generosity of Jacob, Ralph, and Alex's team, we do have take and makes available at 5 of our branches where you can create a constellation out of the materials and make up your own story. And these 5 branches are Hamden, Patterson Park, Reisterstown Road, Roland Park, and Waverly. And of course, these are available on a first come, first served basis while supplies last. So if you didn't have a chance to stop by yet, please do so soon. I do not see anything else coming through the chat. So before we conclude tonight's program, I guess I just want to ask Jacob, Ralph, and Alex, is there anything else you'd like to share with our participants?
Unfortunately, my browser is frozen again, so I don't think I can show any.
I think we lost him. Right. I just wanted to share maybe a sense of scale for the things we've talked about so far. So we've said the word light year many, many times. And I just wanted to explain that just like it takes you to some time to get to the store, it takes time for light to travel through the universe. And so it takes light 8 minutes roughly to get to the Earth from the sun. It takes light about 100,000 years to cross the Milky Way galaxy that we exist within. And then the nearest star is maybe 5 light years away. But the nearest galaxy to us, the Andromeda galaxy, which we mentioned before, is 2 million light years away. And so when you're looking at light from Andromeda, the light you're seeing was emitted 2 million years ago. And so the galaxies we've talked about have been maybe 50 million light years away. And so they're 25 times further away than the nearest galaxy, Andromeda. And the galaxies that Alex showed in the Hubble Ultra Deep Field are much, much further than even those. And then the other thing I'll leave you with is that the stuff I work on is actually stuff that's much closer to us. I study planets around stars other than the sun. And most of those planets orbit stars that are just probably a few hundred light years away. So we're looking at a very small area of the galaxy, but I'd love to answer any questions you have about planets around other stars, which are called exoplanets.
So I did see another question come through in the chat. Does anything in a galaxy slow down light as it travels through the galaxy?
That's a very good question. For the most part, light just tends to either bounce off of things in a galaxy called scattering, or light interacts with some stuff in a galaxy and just gets absorbed, and then we don't see that light. But there is one type of light that does kind of slow down as it travels through the galaxy. We talked about radio waves, like the radio waves we use to transmit music or transmit the radio you listen to in the car. As radio waves travel through the galaxy, the radio waves that are slightly have longer wavelengths, just like redder light has a longer wavelength than the bluer light. These radio waves, depending on how long their wavelength is, speed down a different amount. And so just by figuring out, by looking at these radio waves and how much they've slowed down, we can figure out how much gas is between us and the thing we're looking at. And we can figure out how far away that thing we're looking at is. And so it's only that specific kind of light that sort of slows down.
Thank you. And there was another question that came through related to planets. How many potentially habitable planets do we know about?
That's a great question, and a very hard one to answer. And it's a thing that people who study these planets are putting a lot of work in to study. So far, I mean, the first planet around a star like the sun was only discovered the year I was born in 1995. But now we know of 5,000 possible planets around other stars. And of them, I'd say very few are possibly habitable. Something like maybe tens or hundreds of them might be maybe habitable. But habitability depends on a lot of things. Most of all, how hot is that planet? Just like if you hold a marshmallow a different distance from a fire, sometimes the marshmallow gets burned. Sometimes it doesn't get quite as toasty as you'd like. These planets, you want them to be just the perfect distance to have liquid water on their surface, because life as we know it on Earth requires you to have liquid water. But there's many other things that affect whether or not we think a planet could have life.
And we did get a pretty fun question. What is the strangest planet you know about? Is there anything that stands out to you or strikes you about any planets that you know of?
Well, I'd say the planets, some of the planets I study the most are pretty strange compared to what we expected based on the solar system. So in the solar system, you have the inner planets, Mercury, Venus, Earth, and Mars. They're small. The closest, Mercury, has an orbital period of 88 days. Here on Earth, we have 365 days. And then further out in the solar system, you have the giant planets, which are on much longer orbits, and they're much bigger planets. Jupiter is roughly 300 times heavier than Earth is, and 10 times wider. But then the very, very first exoplanet we discovered was the size of Jupiter, but it orbited its host star in just a few days. And so if you take the distance that Earth is from the sun, it's just almost like 100 times closer to its star than Earth is from the sun. And so that's a whole group of planets that we call hot Jupiters, because they're close to their stars, so they're hot and they're the size of Jupiter. And so there's many planets that are pretty weird compared to what we expect, and we were pretty surprised to find them. But there's also planets where they rather than going around their stars in the same direction that their stars are rotating, like happens with our planets in the solar system, the star is rotating like this, and the planets are orbiting in the other direction. And that's weird because we would expect, just based on how planets form, that they would have been in that same alignment. And that's just one example of a pretty weird planet.
Well, that's all really fascinating. Well, thank you so much for joining us tonight, Jacob, Ralph, and Alex. We're so happy you could be here to share a little bit about, stars and planets and some of the stories that are associated with them. And thank you for being a part of Imagination Celebration. And again, we've got programs happening all month. Please be sure to get out to those 5 branches I mentioned earlier: Hamden, Patterson Park, Reisterstown Road, Roland Park, and Waverly, to pick up your Create a Constellation take and make. And we hope to see you at other Imagination Celebration programs this April. So thank you, everybody, and have a great night.